I mean, I will say, I don't know.
Especially around this area right now.
Alright, so we'll get started here. Thank you guys for coming to the Critical Design Review.
Hey guys!
Start here. Got the live stream up, so thank you guys for coming. This is a good turnout. I'm glad we have some external reviewers for this one. Hopefully we get some good feedback. Of course, interrupt at any time. Love your comments. And hopefully this gets the whole team on the same page and then the community on the same page. Really looking forward to this year, and I think this will be a good critical design review. So we've already done pizza, introduction. We got the officers around. I'll be presenting a lot. I guess we'll kind of introduce at the beginning of each section, but yeah, I'm Brandon, project manager. Callie's over here, president, and vice president, Faith doing the live stream and documentation. Yeah, and Garen's gonna be doing some social media stuff, so of course have a good spoiler on him. And John, thank you. Thanks for bringing the drinks, and Nick, thank you for bringing the pizza. Very good job. Thank you. So primary goals, a lot of the stuff we want to get feedback on for electrical and software. A lot of electrical stuff. I heard we have some really good slides coming up, so I'm excited. And then yeah, we'll just do comments, critiques on anything. Everything's just about like half done, I would say. So I think it's a good like midway mark. We got, you know, kind of half frame, got some progress into locomotion. We'll talk about that. And yeah, D-Box is pretty good. We'll go into all the details. So to get everyone on the same page, specifically with how the timeline's gonna go. Because I've been confused. At the mid-year review too, there's some confusion that was kind of funny. But anyway, really big dates. We've got the CDR right now, presentation and demonstration, and the SE paper. Those are two really important massive deliverables on March 15th and April 9th. Yeah, if you have any questions about those are mostly officer stuff. The SVR, that's April 12th right now. But I'm thinking about moving it to April 5th. I don't know if anyone has any comments about that, but I was hoping we could move it to the 5th because then it'd be before the SE paper, and a section of the SE paper, which stands for Systems Engineering Paper. That's a deliverable, 25 points. A section of that is about system verification. So like we could do our own system verification before it and then document that for the paper and then actually like kind of present it to you guys for the SBR on the 12th. But I think it'd make a little more sense if we made system verification more of a encompassing, like had your guys' feedback on it. And I'll talk about some success criteria and actually how we are verifying the system, like as a verb. Proof of life, that's a big date, April 21st. I think we'll hit that fine, especially because I'll go into another time in a second, but yeah, proof of life, that's a big date, and then competition. So now this is kind of more of interest to you guys as the team. This is like structurally what you will see being built up. Now everything's like half done. February 25th, that's a big deadline for mechanical, specifically locomotion frame, like the wheels. I'd like to get all 4 wheels done by the 25th. And electrical and software, tabletop assembly, we'll talk about that in a bit, but yeah, we should have like some really good testing. March 9th, not a big deadline. That should be a good milestone for excavation, and then software should be finishing up some locomotive operation. I'd like to see wheels moving, and possibly, yeah, we'll see. March 21st, that's going to be a big deadline for electrical. After that, it's kind of just testing, but it should be all the main components are in and working to a good level. Full robot, yeah, operational because electrical is mostly done. And then April 9th, SE paper, system verification. I'll talk about that more with this next slide. Unless anyone has any questions. Yeah, with competition.
So real quick, if you have not already, fill out this form by scanning the QR code. Today is the last day to do this. This is just if you're interested in going to competition. So if you're not interested, you don't really need to fill it out. But if you are, please fill it out by tonight. In order to be eligible for competition, you must attend all the design reviews unless you have a valid excuse, participate in at least 2 outreach events, pay your dues, which are $15, and be an active member on the team. So this is so that we can gauge the interest and see how many members we're able to take.
And then this is kind of this has been a work in progress for the past couple weeks, but I really should have started it more at the beginning of the year. I think these are some good metrics that will actually verify our system and show how successful are we, how good is our robot. Because of course I want to do better than last year. I want to do better than years in the past because we always want to progress. I always want to do better, but how much better? So I think we've put together some decent scales. And you guys can look at this in more detail. We're going to talk about this later. But really I just wanted to introduce this as an idea and as like everything that I have so far for it. And it kind of breaks down into like different goals for each sub-team. Mechanical, the first couple, and then software and electrical, watt hours. But like we want to strive for all threes, but as long as if we get all twos this year, it would be good. I don't know if that makes sense, but it's basically like 0 is bad, 3 is good. We want to get better and better. Right. And we'll talk about that at the system verification review a lot. And treasury.
Okay. So, earlier introduction, I'm Jonathan. Mainly right now, everyone's on track. Other than that, we haven't made any travel expenditures yet. That's soon to come. Everything else is pretty settled. A little bit more to purchase on mechanical, maybe some more software, but as far as I know, electricals is pretty much purchased, right?
Yep, should be good.
So, outreach should be done. The general is just open expenses. We might have some money going in the sand pit, but that's still debatable at this point for like the exact amount. So we're holding that off on our estimates. But let me go to the next slide. I will also be presenting our weight budget. So, well, any questions on that last slide? Cool. So this is a running thing I've kind of started is really the design review breakdowns. So we got the 2 numbers from the last 2 mid-years and then where we're currently at. So that's locomotion is currently at 8 kilograms, excavation's at 9, frame is at 7, and integration is at about 8.5. So numbers will probably still slightly go up once we start getting like real measurements and we're not just going off of Inventor. But you know, we're at 32, so I don't see us getting anywhere close to our 40 kilogram limit. And that's just, again, the breakdown of our different systems, where they're currently at. Again, it's matches at 32, so. That's all I have. You got any questions? Yes.
Is that 40 kilograms our goal limit or the absolute limit?
It's the absolute limit. Like, we want to be under that as much as possible.
Okay.
It's our goal. The absolute limit is 80.
Okay, that's what I thought.
Yeah, no, or, yeah. Okay. Is that my last slide? Yeah, all right. Thank you.
So here's kind of an overview of what the next slides should mostly be about. Yeah. For electrical, we're going to talk about definitely implementation. There's a couple little projects, or big projects that we're still trying to figure out. So batteries and limit switches, those are some good topics. Software, of course, we've got a couple good topics with that. Tabletop testing, autonomy, manual operation, want some good feedback on those. And mechanical, yeah, got some good frame. It's looking pretty nice. A couple general questions for not really the rest of this year, but if you guys wanted to, should we have welded? Any more dust proofing that we want to do for this year? But you can look at the drawing, I can pull that up. Camera placement and sponsors for the stickers and stuff. Those are just some good topics, but and now we can move on to electrical with Ray Klein and Eli Michalski.
Good morning. Yeah, today we've got some fun stuff for electrical to talk about. So first off, we are building our own battery this year. We're building we're building them with LiPo battery cells. We're making our own battery packs with that are going to go in the robot. This is because they're a lot cheaper and a lot lighter than previous year's batteries that we've been using, and should hold more than enough capacity for us throughout our competition runs. Unfortunately, we're trying to figure out how exactly we want to connect all these batteries together in series and parallel, and we'd really like some advice on how to do that today. Currently, we're trying to spot weld nickel strips to them, but that is not working as well as we hoped. Next, we want to talk. Well, we've started assembling our e-box, as you can see here. If anyone would like to come see it, especially after the presentation, I'll be price it over here. Happy to talk about it. We've attached our e-stop to it with 200 amp current rating on it. We can make additional things to make it better. Would like some advice. Distribution-wise, we can also show off our aluminum custom-made terminals that we made to connect everything together. And finally, we just want to talk a little bit about e-box manufacturing with anyone, talk about it, see if there was things we can improve for next year, how we can improve this year even if possible. But yeah.
So in addition to the power system, we're also looking for feedback. This year we're trying to go with a Ethernet network system rather than like CAN or something that's been done in the past. So we have a top level network router and switch inside the e-box that allows us to distribute the network within there. And there'll be an access point outside for the remote station. And then in conjunction with that, we're using a distributed control system where each wheel and the pair of actuators has its own microcontroller and driver. We can call this robot over IP. And that uses the Ethernet to provide a separated distributed system where each wheel or actuator is independent in case of failure. And we're also using O-drives instead of SparkMaxes this year, because we've had much better luck with getting closed loop control with them, and that allows us to improve our autonomy. So I'd appreciate any feedback on the current setup we're looking this year, or what you think we could improve on next year.
Yeah. So here's a slide kind of going over the battery packs that I was talking about earlier. Like I said, they're supposed to be a lot cheaper and a lot lighter than we had in previous years. So we're hoping we can continue kind of working off this base for the next few years, possibly using other batteries. Again, we'd like to hear kind of your feedback. We want to see. We feel that these batteries are the best for our robot, at least this year, but I'd love to hear some feedback. But yeah, they should be only about 0.9 kilograms. So we're feeling pretty good this year about the battery weight.
I guess question on batteries then.
What's it?
How much does it cost to buy the pack of batteries that's connected in a way that is, you said you had everything, you had a configuration on the first page. How much would it cost to actually go and just buy a pack of something that was easier to assemble in that fashion?
I could get back to you with a better estimate, but I don't think it was cheaper to go with like a pre-made lipo.
Well, and I know it's not gonna be cheaper, but you also don't have all the labor.
Yeah.
You don't have the possibility of damaging because you don't know how to weld them, you know, and connect them together in a way that's, you know, so cheap is not always the best.
That's true. Yeah.
That's a good question. Cheap is also not always about cost because we have time.
Yeah. We'll try and get back to you on that though and see how much exactly it would cost.
Yeah, well, no, I don't even need a number, but I think you go through, you have to look at your ability to manufacture that as well. And if you're struggling to manufacture it, it takes you 100 hours to manufacture it. You know, I mean, if your time right now is totally free, so, you know, you're right, you did nothing there, but what happens if you don't get it, or what happens, or how would you identify that battery with that battery damage with you welding it? I don't know what's inside there. I have no idea what's inside of that.
Along the same lines, have you considered purchasing a battery box where you would have connectors in the box so that you can insert the cells and then you're just wiring the connectors together to get the right voltage versus wireless. So that way you can take your existing cells, put them in your container, and just get them done as connectors.
I like that.
Yeah, or if you have to manufacture that box,
Yeah.
those are not a standard cell, but you can still get the connectors that are much more easily wired.
We'll definitely look into that actually. I'd like to see if that's a possibility for us.
That sounds good.
And then finally, just wanted to discuss a little bit about our tabletop testing methodology. That first one actually could change. That's actually due February 28th or 24th actually.
We are waiting on a couple of things, so it is really just kind of dependent on when the hardware comes in. I wanted it to be 25th, but 28th is okay.
But yeah, that's the biggest problem we're running into. We're waiting on components. They're estimated to arrive the 18th to populate the PCBs.
With some of the hardware arriving later, do you have any plans for if a part is damaged closer to competition? Do you have spare parts? Do you know the lead time that manufacturers would have? Ship times? Has that been thought of at all?
Yes, a little bit. So we did purchase extra, so we have 2 spares of everything we need on the robot. But as well, if we need faster shipping, we can go through some place like DigiKey. The shipping will be much quicker. It just is more expensive.
If you guys didn't do like some kind of onboard state of charge batteries, reach the 1 liter across.
Currently, we don't have anything like that. We will have a BMS to protect it from overcharge, undercharge.
Okay.
But we don't have a meter at the moment.
That would be something we'll do include next year. I haven't worked on that yet.
But anyway, with the testing, our general plan was to get at least one type of everything hooked up on the table. So like a O-drive and wheel combo, an actuator module combo. Hook that in with the Jetson, the router, the switch, get that all powered up and try and test it overnight to find reliability of not only those electrical components, but also the feedback sensors. So we want to make sure and calculate like how much, say, the actuator encoder is going to drift over time during operation.
With this battery management system you guys are looking at, how difficult would it be to sort of find like discharge? Like, I'm thinking of like how laptops are, where like if you go into your power settings, you can sort of see like a graph of like how your battery discharges, and you can glean some info about like battery health through that. Would you guys be able to like chart like charge time, like voltage across charge time, and like or like current across? Like, would you guys be able to like get battery health metrics using the battery management system?
Unfortunately, I don't believe so. This is just a protection module. rather than something like that monitors the state.
Okay. All right.
That would be a good thing to look into for next year, though. We'll definitely look into that and see if we can get a new system that can do that.
You might be able to look into doing that with like a Jetson, maybe, like sort of take that to software, maybe.
That could be. I mean, we will be able to monitor the bus voltage from the O drives. They all provide nice feedback of that.
Okay. All right.
What's needed to implement the battery management system? Like, have we selected the hardware to connect everything to, or and does that like connect to each battery individually, or is it just kind of like, okay, this group that's in series is managed, or can you like just for the people who don't know, elaborate on it a little bit?
Sure thing. So how it works, we have our battery. There will be 5 in parallel, and then there will be 4 sets of those 5 in parallel connected in series. And so effectively looking at the voltage across each battery, all the parallel sets act as one battery. And so it's a 4S BMS. It is responsible for balancing each of those sets of parallel pairs. And so that maintains that each cell in those series would be within the correct tolerance. And it also protects for overcurrent as well.
And do we have that?
It has been ordered. All right, yeah, I think that's all.
Thank you very much.
Alright, so hey everybody, I'm Jackson. If I seem a little out of it, I am a little sick. But without further ado, we'll get into it. So we've been making great headway on software. The remote station is done. We are finishing up tying the Q package and ROI together. Once that is done, we should hopefully be able to do table testing and manual operation of our robot. So once that's tied up, we can go ahead and start doing that, as well as have a great foundation for autonomy. Speaking of which, once that's done, again, we will be getting autonomy and going full steam ahead on that. We plan to use something called Ross Isaac. And one thing that I do not have up here that we will be focusing on once we kind of have a lot of our design and structure organized and completed is documenting stuff on GitHub. Predominantly right now we are planning on using markdowns. If anybody else would have a way of organizing this information or making sure that we don't lose it over the years, we would love to know that because obviously that has been an issue that we have struggled with in the past, and we are trying to remedy, especially this year, by making things more modular and reusable. So yeah, if you could go to the next slide. So as I mentioned, we started, or are finishing up the Q package. One of the main things about the Q package was conflict resolution, i.e. if I press 2 inputs and they conflict with each other, all right, who am I going to listen to? We have broken down all possible movements into types. We have using this button. I think I might have actually mislabeled one of these, but actuator, control, and wheel. Basically, actuator doesn't conflict with wheel because I can still walk and raise my arm at the same time. That's fine. But let's say that I tell my arm to go up and down at the same time. Okay, well, that's not going to work. So those will conflict with each other, and whichever one has been last pressed will be taking the priority on that. And let's say I hold down arm up and arm down at the same time, right? It's going to listen to whichever one I was, the last one that I pressed, but let's say that I pressed arm down last. It'll go down. Once I lift arm down, it'll go back up because it'll have stored the previous up input. So that's how we're doing conflict control. Any concerns on that, let me know.
Yeah. Shouldn't you just ignore all inputs if somebody's holding the up and down button? I would assume you should go, I don't know what the heck they're commanding you to. I will do nothing instead.
That's very valid. That was one thing that we considered. Really, it just came down to personal preference at that point. So yeah,
We could be programming both and then just have the driver figure out which sort of system that they like better and then go for that competition.
it's not that hard to reverse it anyways. The main thing is knowing that these things conflict. That's the big thing. The what to do after, that was just kind of debated for a little bit and settled on because it's pretty easy to switch. But that's how we're doing conflicts. Any questions or concerns on that, let me know. I love the question. Yeah. So if you could go to the next slide. Oh shoot, actually, go back one, sorry. John is going to talk about the way that we're going to do autonomy for a little bit. We're planning on using Ross Isaac. Admittedly, I don't know much about it. That's mainly this guy's field of expertise, so if you want to swap closer.
So we will be using Isaac Ross. It is a package developed by NVIDIA specifically for the Jetson Nano. It uses the GPU to offload some of the tasks of figuring out where we are, where we need to go, pathfinding, and everything else that we would need. And so we're planning on using this to use April tags to figure out where we are in relation to the arena. And we're going to be using a sort of waypoint system of we want to go here, we are here, find the path, and go that path. We'll be using that system. We will also be using this in conjunction with behavior tree, so that way we can say, all right, we are wanting to do a dig cycle. You go to this location, you put down your bucket, you drive forward, pick it up, go dump. And so that is one full path. And so that allows us to do it graphically based, and it should help us with planning all of our actions and how they operate. We'll be starting this as soon as all controls are done for the general system.
Questions, comments, concerns, exclamations even. I'll take anything. Thank you. All right, in that case, I think we're going to hand it over to Mechanical. Thank you all for your time. Appreciate it. And yeah, let's go to the moon.
Hi, I'm Nick. I'm the mechanical manager of this. So first up is our mechanical progress. We have machined many of the parts for our frame. Oh, TD? Yes, this version is held together using tape.
Saves on weight.
Yeah, so our actual plan is not actually tape. It's to use these connector blocks that have screw holes that align to these holes right here, they're hard to see, in the frame extrusions here, which go into the motor. So it's just an already existing bolt that helps us keep this extrusion. Yeah, those are all bolted to the frame. So this will slide right into the end and it acts kind of like a cap. These bolts here, they are meant to bolt directly into these holes, which will then secure the outside frame brackets. It just makes it a nice, clean and simple way of having our bolts facing us so we can pop the wheels off. 6 bolts each side. You can take the entire side of the frame off and access the motors however we need. We also have a pressure excavation system manufactured as well, and dust covers that function as spacers and mounts for our motors as well. We'll talk about those later, I believe. John's been putting a lot of work into that. So, oh wait, over here, right? Yeah. So, John, like, come on up. So what we have left to do is finish assembly with locomotion and frame. we obviously need to finish manufacturing these guys and make sure our bolts connections are good, as well as assemble the excavation frame that will hold our excavation system. On top of that, we also need to assemble wheels, but I'll let Johnny get into what would be done for locomotion.
Yeah, the current status of the wheels, we're really being delayed on waiting for manufacture. This right here is part of our male end of our coupler. It's kind of the core of our wheel. So we're currently just waiting on the other half of this, essentially, to be manufactured in the machine shop in this building, actually. As well as we ended up ordering the wrong thickness metal for our grousers. So we had some issues with that. So we had to reorder a different sheet. And now we're waiting to get it into the plasma cutter here in ASEC, so we can cut those out again. Other than that, most of locomotion is not essentially not assembled, but in pieces. So that's kind of really the current state of things. Any questions? Yes.
Same question that I had for electrical. Do we have backup parts, spare parts? Do we have any plans for that?
So we pretty much made it at least one spare of everything. We have 2 extra wheels. You know, there's an extra extrusion, stuff like that. I mean, technically I can print a few more extras, but we'd also have the capability of printing things, 3D printed stuff there. Some of the long prints, we won't want to do that, so we will make some extras. But I think, there's like 1 or 2 extra pairs of like the wheel coupler and stuff like that.
Yeah.
So we're already counting for it. Usually at least 1 or 2 extras.
Additionally, the grousers, we can crank those out real fast with a plasma cutter, and they're designed to be the most disposable part of the wheel. So if one shears off, breaks, bends, cool. Just drill out the rivets, pop a new one in. We're good to go. Any other questions or comments? Exclamations?
How is the
Wheel tension?
Yeah.
Yes. Oh, yeah. So plans for that. We are going to need a way to hold the hub of the wheel centered relative to the rims. Plan for that is to use a 3D printed fixture for that, hold everything in place as we connect steel cables from the hub to the rims. So that way we have equal distance for everything. Tensioning, it's not going to vary too much across each spoke in that state. So the plan is to equally tension them all using the coupler in the center that we talked about at the last review to draw the hubs inwards, which now that we have some of the bolts here, see the threads on here, coupler in the middle, rotate the coupler, and it will draw the threads in on each side, which brings the spokes together.
Are you going to keep some of the grousers off while you do that?
Yes, that is the plan. Additionally, currently I'm working on putting holes for tension screws into the wheel hubs, or the wheel couplers rather, so that we can lock our hubs in, keep them tensioned, not have to redo them. So that'd be a pain. And eventually, additionally, like to put Loctite on them to keep them in place as well. All right, thank you.
Thank you guys for coming. It's just open to discussion. If anyone wanted any slides brought back up again, or if you're just free to mingle and talk to different people in charge of different things. Thank you. This has been good.
I do just have one comment. As far as the general meeting, people that don't come and visit your facility very often don't know what any of this stuff looks like.
Yeah.
And so, I can see that there's a box down there that's possibly an electrical box, possibly the one you're using.
Yeah.
But there's no picture of it, or the mechanical stuff. There was something that maybe was the wheel, or to ask for input on stuff that you didn't show anybody can be very difficult, you know, to get through, because you now don't, I can go over and talk, but what am I talking about? You know, I know the electrical guy said, oh, he'd like input on, and they listed 4 or 5 different things.
Yeah.
You know, then they didn't talk about it. You know, talk very little about it. So I think we can go through to a big group, you know, go through and at least have some points of, you know, this is what the design is. Right now, nobody that hasn't remembered the initial review have any idea what the robot looks like that you're trying to build.
Yeah.
You know, and so some of that detail for the outsiders that are coming in, you know, will be super beneficial.
Yeah, they'll just email out before the review. That's homework to do on their own time before we can hear some of this.
Yeah.
We usually try to get the email out before, but we're just a little delayed with this one.
Yeah. Would you like me to pull up the picture of the robot?
Yeah.
I'll pull up the presentation.
No, because when you get to industry, by the time you get to a critical design review, they can just be brutal.
Yeah.
So it's not just a gloss over, this is what we're hoping to do. This is no, that resistor value is wrong. Why did you put it there on the board? And you get everybody's absolute picky, you know, digging at every aspect because everybody wants it to be right.
Well, then you get, just, you know, in addition to just a critical design review, you have reviews that involve every facet of the department at something. So you're dealing with industrial design, marketing, sales, engineering, operations. So they're all going to bring their different perspectives. You got to put enough information in front of them that they can understand it before they can give you good feedback.
Yeah, that's fair. Those are good comments. Thank you. But yeah, you see the vision that we have? We've got a nice spinning robot. So that's obviously the base, and then there's some extrusions that have come up. Those will come up to support the battery box, which we are using that one. You can mess with that however much you want. But that'll go up on the top rectangle, which just supported by extrusions. And the top rectangle also supports the excavation system, driven by 2 actuators, as you can kind of see. Yeah, I don't know. Any questions about that?
I guess I have a question for maybe mechanical?
Yeah, sure.
Why did we place the e-box on top of that frame instead of inside that little box area?
We want batteries
lot of
going.
space.
Okay.
Yeah.
Channels it up, quite cut it.
Okay.
Are we still doing the battery drawer?
That's the plan.
Yes, that is the plan for
Yes.
Is someone modeling that?
This hasn't been at the top of our priority list.
That's fair. Yeah.
Working on getting frame ready, but might get that go through to here. We're electrical, you know, dimensions, specifications down.
Yeah.
The idea for that, for anybody who's not familiar, the idea is to have a drawer for the batteries. You can just pull it straight out of the robot, for easy maintenance. You can pull them out to recharge or fix anything by chance. Makes it nice and simple.
Who had questions?
Are you guys sticking with LiDAR again this year?
Not LiDAR.
Which one? What sensor pack? I forget.
We're using depth cameras, so
Oh, that's right. That's
yeah,
right.
they can actually gather.
Sorry, I couldn't remember.
All good.
So where are those going to get mounted on?
So that is a question which we've been asking ourselves for a long time. We are going to mount one on the back, about right there, and then
will it be on top of the e-box?
again, it's one of those things where we're waiting during the full robot assembly so that we can get, all right, what is the most comfortable for the driver? It's one of those things that could be very easily mounted on.
You were talking about. Remember we were talking about having them extrude up to the side of the frame like that. Because Jacob had his boxes. Yeah. Would that work? Do you have any comments about that? Having the camera
you could put them there, but I mean, if you put them on one side of the camera, the opposite, or the robot, the opposite 180 degrees, you can't get able April tag ready to run, so you'll be driving blind on that side. But
Yeah.
you want them high, centralized, and ideally really close together.
But to answer that question, we don't have a definitive place for it yet. We know that one is going to be on the back, and we know that one is going to be on the front, whether it's mounted to the side or if there's a better mounting point, because our biggest concern is that the bucket will be obstructing the view.
How much spare bandwidth and budget do you have to get a third camera? Because you could maybe put one camera on each side of the board to try to look past it.
Yes, so we have two really good expensive cameras that are the depth cameras, and we have been talking about having a really crappy, like rocket fish one, almost like your van's backup. Not to diss anybody's van's backup camera. I'm sure they're all very good, but we might throw one of those on the back instead. That way we have mounted on both sides. We get a decent field of view.
You guys over the April tax again? I was going to ask John this after, but are they in April tax like the QR code? They're in the arena.
Yeah, so we get to place one. So the idea is whenever we start navigation, so we start in a little box, the direction of which is randomized. We would have one there so that at the beginning of navigation, basically we would turn around until we saw our April tag, and let's say we put it to the north. We're like, okay, this way is north. We need to go that way. So then we'll go to the dig site where we'll have an April tag in the construction zone. Will we have one in the dig site?
Hopefully we can have one right behind the dump zone.
Yeah.
But we're not too sure because it was supposed to be not used last year for competition, but it was for some teams.
It was a little weird.
I don't know. It's something that we'll have to look in the rule book for. Having one April tag should be
One April tag I know is fine, but we're thinking of having it at our navigation spot so we can orient ourselves. Say this is north.
You should have more than one in the beginning area. You should try and fill it up at least two, like as far apart from each other as possible. So that way you can just get more accurate measurements. Like just instead of just one, you could have two, and it would be just as easily because April tags come with their own ID. Like whatever pattern it is, it's ID number one. So then you can just know, hey, these two are going to be a meter apart from each other, therefore we're here. So that way, if one's blocked or you don't see one, you still have duplicate April tags.
It's one of those things where it's definitely better to have more. It's just what fits within the rules.
You're allowed to have it.
I wasn't sure how many we could. I know we can have at least one. I wasn't sure how many we were
You're
allowed.
allowed to place basically whatever you want in the starting area. I don't know about outside.
Jada, so with Isaac Ross, we will be using something similar to RTAB. And so that will be taking in information from the cameras and depth sensors, and it will be making a map. And so basically everything around the robot will be that April tag, telling it where it is.
So you just need the one April tag to determine Jake's direction.
Correct.
And then sensors will gather other points of data using that as a reference.
Correct.
For a map.
Yes. And so we will be able to tell where we are in relation to that April tag without even seeing.
It's like having a compass.
It doesn't have a number limit.
Sorry, what?
It doesn't have a number limit, and then you see there's a bunch of holes here, so you can pretty much do as many as you want.
Gotcha. So it does not have a number. Yes, go for it.
So you've expressed concern about the visibility in front of the robot.
Yeah.
In particular, relative to the bucket, you notice that on the bucket arm, there's a cross member right at the highest point of that. Have you considered relocating that to improve visibility?
Are you talking about that guy right there?
Yep.
Yeah.
Or we're gonna have accurate
position data on the arm. We have encoders on those actuators. We will not put the camera on those arms because we're going to have our hands full enough doing the autonomy without having to worry about the camera moving relative to the structure of the robot. One of the things that we're trying to do is keep it simple. One of the issues we ran into last year was people were doing LiDAR before we even had the wheels running. So we want to make sure we build a good structure that's reusable. So don't want to make it too complicated there. As for removing that bar, I would have to talk mechanical, but again,
Can you relocate it to reduce how much it's eating?
we could look at that. Especially for last year, I don't want to push mechanical because they did have a design freeze.
Yeah.
Yeah.
But it's also a question of like how much the bucket in the middle is getting in the way. Do you have a good?
Do you mind repeating which bar? I mean, the one right before the bucket.
This guy.
That guy. Yeah, that's the one you need someone to do.
Yeah. I figured as much.
Plus, you can get us like a super short, like a 3-inch long actuator with a 6-inch stroke.
Oh yeah. Yeah, I can do that. Let me break out my bag of holding. It'll work.
I understand the concerns about mounting the cameras on any part of the dig arm because it'd be moving and that would be really complicated. But hear me out. If you put the cameras on top of the bucket like little eyes, it would look adorable.
Fair point.
It's also more cool to view if it moves, right?
Yeah.
No, I have googly eyes for that. Yeah. So there's a lot to be discussed with the camera position. As of right now, we have been pushing that back and mainly focusing on making sure that it's set up for manual operation because I want to make sure we have a good foundation before anything else. Because autonomy, actually the way that we have it set up is it spoofs manual inputs as well. So we have to make sure that the manual's working before autonomy's working. And also, if autonomy wouldn't work anyways, somebody's going to have to take over and they're going to have to be able to see. So that has been a top priority. What's best for the driver, not what's best for the autonomy. Which is, we can't necessarily find out until somebody's actually driving it.
Okay. One more question I had is just on the for the wheels. It looks like you're using spokes in the wheels, and I've never personally actually put together a wheel with spokes and adjusted the spokes. But for a wheel that small, that seems like it might be a little early when the weight savings compared to just using a solid hub seems negligible for such a small wheel. It'd be simpler to have a solid hub. So just wanted to ask about how confident you are in the spoke assembly.
Yeah, it's primarily experimental. Worst case scenario, we can always convert it to a solid hub system. There's those little circles going around the inside of the circumference of the wheel. Those we can cut out our own ribs and bolt it directly to those. That accepts an X shaft slot, and it will function just like any other wheel we've done before.
Is that a quick modification that can be done?
Yeah, it's really quick.
Use
Like
plasma
just go
cut
down
down.
to the plasma cutter, it's
Yeah.
done in maybe, I'm not sure how long, but definitely one sitting, and then bolt it straight on.
I was going to talk to you about it, but we also have John's design too.
I'll run too short on notice.
Yeah.
So the idea behind plasma cutting out the insides for the backup plan is almost like converting it into John's design in a way.
If you have some people just lying around, not doing anything, you might want to get them to model that just in case. Because realistically, the longest thing that it's going to take for that adjustment would be the modeling. And you can have somebody working on that way.
Yeah.
Just an idea. If they're not doing anything otherwise.
Yeah, of course.
Yeah.
I've got designs lined up.
Gotcha.
Question for electrical. It was brought up at the beginning that it would be helpful to have a lot more pictures and stuff for people who haven't, been there every week. Do we have a electrical electrical circuit diagram of any kind, just like a top level view of the big stuff?
Yes, we do.
Okay. I just think that would be helpful to either share, email, or bring some next deadline for you.
Yeah, I'm going to pull the doctor up.
We'll make something, but that whatever it is. That's
Any more full team questions?
Any questions about, because yeah, some of this stuff has been presented in the past, and we should have probably just reintroduced it for this one, for sure. But yeah, any questions from previous things that have kind of mostly been decided on, but you can still take feedback on? Any big topics?
I might not remember because I think in the latest presentation, but it looked like those motors kind of separated into two separate boxes, which right there they look like they're in one box together.
Yes, that was a big change, and that needed to happen. Originally, this was going to be, Nick, do you want to talk about it? Or separating the, John, did you want to talk about this?
There was an issue.
Yeah, no, I remember.
There was an issue because the shaft is holds the motor internally inside the motor. So like we wouldn't be able to actually assemble the frames of the robot, or like if we wanted to service a motor, if anything happened, we wouldn't be able to actually remove it from the frame. So that's why it took into like a separate two assemblies, and then that's why the frame really ended up so modular, because the shafts are held onto the motor internally. So that's like the shaft of the motor, that's essentially just one whole assembly, and we wouldn't be able to, like in that bottom assembly, it'd be impossible to ever do anything with it. So that's how it ended up in that kind of configuration. Okay.
Yeah, that's a good one.
Another question looking at the newer frame. I noticed you've gone from having kind of this triangle shape to having a square.
Yes.
Do you have room or provisions to add a strut in there? Just looking where the arm's attached. The entire square is going to want to do this. So you might remember to hold the top.
Square is held together via the center as well.
Okay.
And we are going to be using brackets to keep that very rigid. We have holes for bolts and connections at the bottom to help with the sway. We're not expecting much force to make it actually want to move.
No, that's fair. It's more of a question of, while it's still a machine shop, if you want to have plans to potentially add bolt holes in case you need to add that structure. Well, actually, I was going to say about the idea of putting the camera up on that middle arm, like the little strut on the arm. If Ford's assembled, if you want to add bolt holes in case you decide you can have to do that to make it harmony work, that would be the time it's easy to add.
To add on to the excavation system.
Yeah, to add a bolt hole so you can mount the camera there, and if you never mount the camera there, you have one bolt for it. But you don't have to disassemble the entire thing to add that bolt hole.
Oh yeah, so the idea behind this is we just have that top cross beam.
Yeah.
All we have to take off is the actuator connection points for that specific piece of frame. And they're not showed in this picture here, but the air stress we're using, air springs, self-contained air to stabilize the whole system left and right. If we need to take out that cross beam, go back to that. We take off the excavation, we take off the actuator connection points, take off the air strut connection points, and then we have 4 bolts on each side. We just have to pop out, and that whole piece of extrusion will slide right out. Okay. And from there, we can do whatever machining we want to do.
Okay.
Yeah, that's a good question too.
Oh, also add that those bolts go in similarly to the locomotion system with the piece I was showing off earlier. Okay. So it's a similar concept to that, just bolts going straight in to the connector block inside the extrusion.
Okay.
Jackson, did you want to talk about any sort of like ROS diagram? Was there something you wanted to add still?
Yeah, so unfortunately, last night I got everything running on ROS, but I didn't have RQT installed on my computer. so I couldn't just get one of the ROS diagrams up and posted on it. So that's my bad, not complaining on my part. Most of this has remained relatively the same. The reason why I didn't want to bring this up is because this is a little outdated. You should, at some point, you think you can get it up and running? Yeah, I think John can get the RQT graph up for y'all. But same general idea. We still have all the packages. The MCU we renamed to ROI, Robot Over Internet. That still needs a little work. Queue package is pretty much done. Control queue node is the only thing that really still needs work. There's an extra node here called macro conflict. It's just macro conflict. Yeah, and that deals with the conflicts that we were talking about earlier. Besides that, it's pretty much, RS is a little different. We have Joy node. There's a ROS package out there, pre-made, called Joy. It takes in joystick inputs, which we then pass to another node, which is called Twist something.
Tell me what's Joy.
That one. And that converts it into a topic which we use, which is then passed into, it's no longer called the priority node, it's now called MUX, which is short for multiplexer. So anybody who takes DLD, you know what that is. You're with the in-group, congrats. And that differentiates whether we're listening to autonomy or human input. That decides who gets to actually talk to the conflict node. It basically says if anything's coming from the person, stop listening to autonomy. Again, at this point, a driver always takes priority over autonomy. As lame as that sounds, that's realistic.
If driver takes priority, do we have a macro button or setting to start in autonomy mode?
We do.
Okay.
Yeah. In fact, I don't have the button messages up, but if we went back to the conflicts, there was one branch called control, and under it, it was autonomy enabled. So there is a button for that. Yeah.
Notice it looks like you have a microcontroller that's actually on the network, and they're talking to your node drive motor drivers.
Yes.
So the node just enable motor drivers. So you guys are able to find it.
I'm sorry, can you say that again?
Right now you have a microcontroller that's on your network, and that talks to the node drive motor controllers.
Yes.
Or the node just Ethernet enable motor controllers that you can use, so you just remove that microcontroller.
So that's kind of an artifact of us choosing the motor controllers. During the time over the summer, we had already decided that we wanted to start going ahead with the ROI, but we had not decided what motor controller to go with at the time, or even motor for that fact. And this kind of lends itself to the ability to swap out parts very easily because we have our own design module for our system, and it's very easy to change who it talks to at that point. So that's why we did it that way. Because if we went with a motor controller that had Ethernet in it already, and we wanted to switch, we would have to design this again. So yeah, we'd be up the creek without power. So that's why we did it that way. Eli.
If I could also just add, because I was part of that decision making, I do know there are motor controllers that run on the EtherCAT system. I wasn't aware of any that run on the standard Ethernet network side. No, I believe those two were fundamentally incompatible.
No, that's fair. I mean, I don't know if they're existing. Just that might exist. Instead of that.
That's So there's that.
Do we have? I know we have a GitHub. I know it's a work in progress. Is there any clear spot in the GitHub where we list out key terms, key variables, key identifiers that we're using in each package? I'm thinking about a list of button inputs to macro names, what the macro names do, what control scheme we're using,
We do. It needs updated.
Okay.
A lot of that is because when the original 2024-2025 documents repo was made, we did not have a lot of our. We were at this point.
Yeah.
There was still a lot of designing that needed to happen, so that was very preliminary. So we're kind of holding off until we're a little bit more finalized, especially with the tele-op, before we really start digging into it.
Okay.
But if you want, in the meantime, you can open up your Docker, run everything, and then ROS to topic list, and it'll show you all of the topics, which is kind of nice. And that's how I'm going to be writing the documents. All right, yeah, bring it up here. Big round of applause for John, everybody.
Hi, Dad.
Hi, Mr. Banning. Alright, so RQT, this is our completed, or what is completed for the ROS node diagram. Yeah.
Don't know why that's not connected. It is in the code. We'll figure that out.
Got it. Yeah, it can be a little temperamental at times. You just gotta show it who's boss. Yeah, so as you can see, there's the conflicts node. After this is where the ROI would be put in. John, take it away.
Alright, so over here we have our reader that takes the input from the joystick and it puts it out onto our joy node, or joy topic. And so our remote controller interpreter, it takes in joystick node and mixes all the buttons to be put in a way so that we can dynamically change the buttons while everything is running. We could change what each button does however we feel like. So that gets put out onto this RS cost node. It goes into our mux. If we say go on runs into autonomy, it switches to the autonomy control. And if we send anything that's not 0, it will switch back over to manual control. So I'll go into our conflicts node, and that will be where we determine what is being sent as the final control scheme. So that's where Jackson was saying you can walk, but you can't tell your arm to go up and down.
Can you point to where on this diagram it transfers from being in the remote control box to actually going to the
So this node will be sent from the remote station, and the autonomy and this node will be on the robot itself.
Yeah, we should. RS stands for remote station. We forgot to mention that.
Okay, cool.
Yeah. And when we say tele-op, that's controlled by a human. Teleoperation. Sorry about that.
Is there anything else?
Anyone ever looks at you like they don't understand what you're talking about when you say ROI for your control? ROI is really commonly used for return on investment.
Oh,
so took me a minute, but I got there. So just FYI.
Yeah, we also double as the financial branch of robotics. Wait, double that.
Bring the bowl quite a bit.
Yeah.
Did you have any discussions about keeping the autonomy actually back on the remote system and just streaming back sensor data and have the bigger computer remote that can do autonomous processing before sending commands back to the robot?
We haven't had too much of that.
Well, I think you're making the right call. I would say that's something to talk about system engineering paper.
Yes.
If you thought about that, made that call.
We did,
just
a tad. So at competition last year, one of the teams had tried that. They had their autonomy running on their local laptop, and they had their robot sending information back. that worked fine at UCF, but when they actually got to Kennedy Space Center, where they have the 8-second delay, it was throwing a fit because it said, "Hey, start turning," and it was seeing that it's still in the same spot. It was like, "What's happening?" And so it just kept on trying to turn, and then when it's like, "Okay," it just got confused, and so that's we would have to.
Totally. If they're implementing 8-second delay, I wasn't aware of that. But that's
Yep.
yeah, you have to do that.
I think in competition this year, isn't there still points awarded for minimizing power usage as well as minimizing communications?
Yes.
Yeah.
So it minimizes bandwidth. You don't have to deal with the 8-second delay. Not to mention the fact that the package that we're using across Isaac, as mentioned before, was built for the Jetson, so it makes sense to run it on the Jetson instead of a Windows laptop.
No, totally. It's
yeah.
As long as you know that this does come at the cost of more power usage on the robot, more weight because you're using probably a bigger, heavier processing unit than what we have.
So we were going to go. The Jetson Orion decision was made last year. So we've been running with the Jetson for a while. So that is a fair point. For us, wasn't even really a thought. Yeah.
It's not optimized, but could it be running on that remote station at all, or is that just it's not?
I think that there is, we could run it through Docker. They have a lot of documentation on that, and so we probably could run it on a laptop. We would probably want to have it running Ubuntu, but we could look into that.
I mean, all of these, you could run technically any of these on your station.
Yes.
Because Ross takes care of the package handling. So that's why it's so nice for us having, if you see, the remote station, even though it's on a different computer, is on the same diagram, and part of that is because Ross handles that so well.
It's all same systems.
Yeah, you don't even really have to worry about it, which is another reason why we went with Ross.
Great, yeah. Thank you for all the software questions have been great. Do we want to pull up any past documentation for electrical at all? Any sort of, because you don't really have a circuit diagram, which is fine. But is there? Oh yeah.
I don't have my laptop.
Is there anything in the OneDrive that we could just pull up, or?
Go to CDA website.
Sure.
Yeah. Cardboard, colored tape, pre-printed prototype. That's the closest thing we got to the sushi package.
I'll go and ask a question from. Is there an overhead around like asking you around the
Yes.
Yeah. Second question. Is that legal? Is that okay? Because I know the rules have been weird about gassing and stuff. And the last time I was on 2018, it was like the last time I was in competition. And I know like we had to use double to gasket our boxes because O-rings are like no freeze and crap. So that was not cool.
Not bumped up.
So I guess there would be like ways for that in my box. I have no.
Yeah, appreciate it.
Yeah, I mean, I'll just check the rules and see what, because I know any of it's going to be in there, lots of things they allow.
If I get like really bored, I'm gonna start trying to get up stuff because I know how that works now. So just like every month, just like the next month, look at what I'm doing right.
What do you mean?
Just like making a document for all of the files that we have, and kind of showing just like in play back how this works. Oh yeah. Yeah. That's what I'm doing right now. My AP
is like to make it like maybe more standardized is like have like to be like meets expectations, like just assigning words to words. So like yeah, so I would say like meets expectations, below expectations, or something. I would say
This is what I was texting you about last night with the things.
Is it great? Yeah, you do that in physics too. You do that in physics too. While you were eating and being the loudest person in class.
I texted you about it and I moved it back. I don't
Well, that's what to make it a little more clear. I was just saying to Brandon, you should have like to be like meets expectations, or like exceeds expectations. Like what is below expectations? Zero is like does not. Or and two is
I know.
Yeah, we were actually just saying this last night.
Aiden, do you want to perchance hit up the union with us after this?
It's only one, and then
Garen's going He has his first season.
Are you going?
Yeah, that's what we did last year. It was weird. I felt kind of bad because we got a picture of like I was like, oh my gosh, just like those stereotypical Discord boxes. And he like walked out of a picture where we take it. I was like, someone just played a Minecraft board on last year. How about you, Callie?
Kelly, I know you have some.
What? Who?
Bring her along.
She said she might want to
And then there's like stands that you can go and shop.
Wait, she's in it?
Wait, Brandon, your girlfriend?
I told
you. How about you? Your roommates are coming to the party.
Oh my goodness, no! They look different.
They look so different. Gotta get them all to the wrong. There's also shops. Like there's little stands that sell like and you know it's looking like R1. Sort of. You guys are using
Alright, we gotta pull it up, guys.
Loading circle time.
I'd like to
Hey guys!
We're look at the diagram really quick. Have some discussion. Yes, this is split up over a couple of pages. This will be the battery and BMS located underneath a UV box. So you got
array of cells here. They're connected through the BMS. That's what cuts off the ground rail to allow the disconnect. And the 12-volt rails just pass straight through the top. This thing goes into our e-box and energy monitoring circuit. So the 12-volt rail will be broken by our contactor that we have, and then we just have the e-stop switch here driving the coil. It's normally open.
For the power monitor, which I know you have to have for the rules off the shelf one, can you get one that shows like current battery voltage and current somehow and tie that into your system so you have
That would go along with what John Donnelly was saying.
Yeah, that would be a good idea. We can look into that. So at the moment, we're just planning to use the one we had from last year. So we're ready. And then, yeah, it's just the actual energy monitoring. It's just going through the ground leg of that because that's where the shunt resistor is. That'll save a little bit of resistance because the wire gauge through it's a little bit smaller than we would like. It's labeled over here. It goes into our power distribution, which is not a lot to look at, but we have the terminal blocks. High gauge wire comes in, and then smaller gauge wire distributed to each wheel or actuator. And then here's essentially the controls and power circuit for a given wheel. It'll come in, go through a circuit breaker, pass out of the e-box down to the O-drive for power. That controls the motor. And then we have power returns back into the e-box over here. And we have the ROI module that's located along with the O-drive by the wheel. And then that gets power and data as well through the Ethernet cable down to it. So there'll be 4 of these on the robot, and then it'll be a very similar idea with the actuators. We just be not using an O-drive, but one of these actually DC motor controllers. That's just a H-bridge. So for networking, got the router and PoE switch here that will be located in the e-box. They have a circuit breaker for them, and then voltage regulation because they require 5 and 55 volts to operate.
Question. How heavy are these circuit breakers? I just want to get you to replace those fuses that probably later. Doesn't matter, like, you can reset it in competition. Hopefully you're not tripping these breakers.
Yeah, ideally not.
Mind if I take this one? It's honestly, it was a lot of a cost weight kind of thing because really we could either get the circuit breaker. I think it was $12 for the circuit breaker. Or we could get the exact same fuse terminal area that we would just be slot fuses in for. I think it was like $11.50. So we figured might as well just go for the full circuit breaker. At the end of the day, it's basically the same. Spend 50 cents more and then not have to worry about buying more fuses in the future.
Okay, fair.
Is the weight comparison not that bad?
Weight comparison was almost identical. Yeah, that makes sense.
That's to be put up. It'll be the Jetson Nano. It has its own circuit breaker, so it's on an isolated circuit. And then it would obviously accept 2 to 3 USB ports passing through the e-box for the cameras, as well as a gigabit Ethernet line directly back to the switch router.
So it's basically battery voltage going to all these individual units, and they regulate voltage down as they need themselves.
Yes.
I assume your circuit breaker is adjustable. One upside of a fuse is if you're in competition and you're having an issue and all of a sudden you start popping a circuit breaker, you're just going to pop the circuit breaker. You could fudge it with a slightly higher fuse to get by. So just food for thought.
That's a good point, yeah. The circuit breakers are time delayed and overspec'd by maybe 20 to 30% of what we're expected to see at
deep draw through there, so we should be good. But that's a good idea.
We'll definitely see that with testing for sure.
Yeah, that's a good. Yeah. Any other electrical questions while we have some of these diagrams up?
I guess, do you have the circuit breakers?
Yes, they're.
And they're going to be mounted inside the box? Or
Already
are they
are.
mounted around?
Yeah, they're already mounted here and everything.
I almost want to pass around the e-bot. Like,
I know. I might walk down there at some point.
Yeah. Okay. Good. Good. Because I'm like, we have a couple of little knick-knack things. You could pass those around. But I don't know. We'll talk about that.
A plan to cover or plug up all those Ethernet ports if you have any unused ones?
Actually, last I checked, we have exactly the amount of Ethernet ports that we will be using. We do technically have these two spare slots right here. We figured we were just gonna make 3D printed covers like we did last year. They're gonna cover them.
That's good. That works. Yeah. Okay. So, any other big round table topic questions? Is there anything else we could pull up the mechanical design? You guys wanted to tear that apart? Talk about the wheels some more. Yeah, I don't know. Anything to make Nick mad. But all right. Any questions about any specific mechanical things? I guess. Yeah.
Do we have? So I just thought about this. The motor. It goes motor, shaft, wheel. Is there any bearings or anything that's supporting the shaft as well, or just?
Yes. So there's going to be a bearing on the outside attached directly to the outside of the bracket. Help, of course, loosen up connection and also help with the cantilever effects from the weight of the wheel robot sagging down. Additionally to that, the mount to the bearing is going to be 3D printed. You also, the plan is to modify it to also act as a spacer too, to distance the wheel to the amount we need it to distance by out of the frame.
It's currently in the process of being made right now. I have a pretty much done prototype, but I'm still messing with optimization and stuff like that. It's still really blocky. So.
I could pull up the full CAD model. How good is that looking right now? I know there's been like a couple little.
So you could do that.
I pulled that not too long ago.
It's big enough they have to look at the full thing.
So that's probably going to take a little while.
Yeah.
Have it open.
Is it this?
Yeah.
Yeah.
Given that the frame is all hollow extrusions, any concerns about collecting and holding on to regolith and making yourself angry?
Worst case scenario there, put holes to drainage, either that, ideally. Find a way to seal that. What that is, not sure yet. But we have options. Not too worried about that. As for the holes, they're fairly tight, like a washer over them. Lots of work on that too. It'll help seal it off fairly well. It might be late a little bit, but it's not that we're actually running this robot in the arena. Just maybe cumulative, maybe like an hour and a half. That's the scenario. Make it all the way to Kennedy. It's not going to be a whole lot. Additionally, we can take apart the robot. Yeah. I suppose we could always add like a drainage plug of some sort, put holes in there.
Also, I don't know if I want to look at CAD, just be like, assuming that I built this with sync, how much the robot does that make? Because, I back it out for the relay station so you don't lose points over it. But, would it be a problem during the run that you got? Hopefully, just two
They would probably help us.
Yeah.
Because our main concern, I don't know about main concern, but a big concern this year is being too light and being, say, a little too front heavy. I expect the E-Box and all its massive size to counteract that quite a bit. But yeah, having more sand in our regolith inside of our frame, that probably helps out. Yeah, not too worried there. show some files in here.
Often need to be incredibly nitpicky. The frontmost actuator, is there a reason it's sitting with the motor up instead of the motor down? Does it help lower some of the gravity? By a very little bit. I love it when good at nitpicking.
Center of gravity is an important. Yeah, that's an interesting note, actually.
Yeah, main concern. Oh, yeah, main reason it's sticking up is just to be really safe with our clearances. Because I'd rather be a little, just a tad more top heavy, and have no concern about hitting our crossbeam there with the motor, depending on our range of motion.
Plus, I imagine it's easy to just flip over.
Yeah.
As an experiment, be like, actually, you can't run it. Good.
Yeah, pretty much. And if when we assemble the robot, it works great that way. Sure, we can do that. And if we put a camera on top somewhere too, that would probably help with our
Yeah. And we considered wire routing for everything. I know it's really hard to
Oh, come again?
wire routing for all the motors.
We haven't had talked recently about that. The wire routing.
Something we're hoping to talk about in the next couple weeks as Frank gets more completed.
Yeah. Only thing we really have to route, they could be, I should say the biggest concern about routing would be that pitch actuator bucket. Since the actuators are designed to move the excavation system completely independently of each other, so you have our control arm, and then our pitch for the bucket, two actuators. That pitch one is not near the frame, it's hanging off on the excavation system, so we have to find a way to pull that wire down. Likely it'll be just running it along a control arm. So yeah, it shouldn't be too much of an issue. Additionally, John's been putting a lot of work in to figuring out wire routings with the motors and motor drives and locomotion frame. We have our O drives right next to our motors this year. Or I guess we're using O drives this year. So our motor controllers are right next to our motors this year. And that allows us to not be running cables, a lot of cables around the robot. We have that close direct connection. There are some concerns I will throw out with the placement of the O drives and interfering with the air struts. We are looking at ways to move those O drives on top of the motors to get them out of the way of where they're now. The O drive is that big rectangular box to the right. Yeah, right there.
Okay. Okay, I see.
Yeah, they're pretty big.
Yeah.
The disc covers?
Yes.
Oh, yes.
There's a full pair of the dust covers on the table right now if you want to look at it afterwards.
Yeah, so that covers all the bases, I think. Yeah, feel free to look through the stuff we have on the table. But thank you guys for coming. This has been pretty good. Definitely good note. I do want to add more of these pictures directly in your presentation instead of doing that. Great job. I'm glad that we could at least provide you the information we have way than other. Was there anything that we really missed? Yeah, thank you guys.